Hi everyone, this is Himanshu, and this is a beginning for our series of the science and technology. And within science and technology, the space technology plays a major role because they usually ask this question almost every year. The one or two questions are always from the space technology. So we'll start from this. So, beginning, we need to understand a few basic terms like satellite. So the satellite, in layman terms, that it is an object in space that orbits or circles around a bigger object. So there are actually the two kind of satellite: the natural satellite, for example, Moon, which is orbiting the Earth, or the artificial one, such as the international space stations orbiting the Earth. Now the satellites are generally characterized by their orbit, the distance from the Earth at which they revolve around the Earth. So we can say that, uh, let me have a good pen. The orbits of the satellite can be the one that we call as a LEO, that is the low Earth orbit. The second one, what we call as a MEO, that is the middle Earth orbit. And the third one, what we call as a GEO. The GEO is basically the Geosynchronous Earth Orbit or the Geostationary Earth Orbit. So these are the three basically, as how we characterize these satellites on the basis of their orbit. Now we'll start with this one, the GEO. Here, the GEO satellites are having, for example, if this is Earth, and for example, like this is a distance, that's A, and if this is a distance that we call the B, and this is a distance that we call as C. Alright, now generally what happens if this is a LEO, this is a MEO, this is a GEO satellite. Now the distance of the LEO itself is somewhere around 400 kilometers to 2000 kilometers. So this is where the LEO comes to the picture. So generally the Earth observation satellites are generally placed in the LEO. Then the middle Earth orbit somewhere around like 18,000 kilometers or less than that itself. That's what we call as a MEO, that is a middle Earth orbit. Generally the remote sensing satellites and some of them Earth observation satellites, they also lie in the MEO, some of them. Then comes the GEO. GEO satellites are basically placed in an orbit of 35,786 kilometers. Now generally we place the communication satellite. These are the heavy satellites which require a heavy engine with a huge thrust so that they can transfer it to the GEO orbit, and they are mostly communication satellites. So now let's start with the GEO 1. Here the GEO basically is at the height which revolves around the Earth in 24 hours. So when we say a geosynchronous satellite, the geosynchronous satellite is basically a different from the geostationary one. The geosynchronous satellite, it actually revolves around the Earth in 24 hours and returns to the same position in the sky after each day. Now that's important. So when you look at the satellite, it appears to forming, if this is an equator itself, so it appears to form a shape of 8. Yes, exactly. Now when I said equator, there is also one more thing you need to keep in mind, is that when we decide the orbits, there is also two orbits. So one of them is basically the north to south, that's what we call as a polar orbit, and the second one is basically the equatorial orbit. Basically the satellite can revolve around the Earth around its equator or from the north to south. Now these are the only two positions where the satellite can be stable. Now that's important concept, I'll explain it here. So if this is an Earth, one position is this one and the other one is here, right? So this is a north to south, this is an equator. These are the only two positions where the satellite can revolve, because these is what we call as a stable orbit. The stable orbit means at that position where the gravitational force and the centrifugal force are balancing each other. Only those orbits we call as a stable orbit. So similarly, the geosynchronous orbit, it can be placed in both equator or the north to south, what we call as a polar orbit. So here, it returns to the same position each day when you see the sky. So it appears to forming a shape of 8, right? That's a geosynchronous. Now when we talk about the geostationary satellite, now this orbits Earth over the equator, first of all. And when it orbits around the equator, when you look at the sky, this satellite appears to be fixed or hung all the time. Means when you see it, appears to be like a star. It's always there. It won't move, right? It's fixed to the, like a ceiling, fixed on the ceiling. It's like that. So they provide a continuous service over a large area. So we can say that it appears to be fixed or hung or whatever you want to say. So this is what basically basic terms that you need to know about the satellite. Now there is also another one which is called the Geostationary Transfer Orbit, what we call as a GTO. GTO, that is a Geostationary Transfer Orbit. Now, the geosynchronous or the geostationary orbit is basically an elliptical orbit. Let me write here. This is an elliptical orbit. And with the apog, okay, I'll tell you what the apog means. And there's another word what we call as a peak. Now, the apog is basically the highest point. The highest point of this thing is 35,784 kilometers, whereas the perigee is basically the low point, which is a few hundred kilometers, somewhere like I don't know. You can check it on internet because some hundreds, few hundreds, something like that. So this is the lower point of the perigee. So this is mainly about the GTO, and next we will read more about the difference between the satellite communications and the Indian satellites and Indian remote sensing national communication satellites in the next lectures. Thank you.